Here's another application. A certain strain of bacteria can double its population size every 30 minutes. So at first it seems like I should use the formula A equals double means 2 raised to some power. So double would be 4, double would be 8, double would be 16. But the thing is, this would be more like if it was a factory that was producing something, and every 30 minutes, so it takes the whole 30 minutes until the product is ready, and then they suddenly open the doors and there's 4 of them. And then you wait another 30 minutes and then they produce 8 of them. And there's nothing happening at 29 minutes, there's nothing happening at 22 minutes. So this I cannot use actually because bacteria are constantly changing. So that is when we need to use the PERT formula. So P times E to the RT. And then we need some numbers. So if you start with 20, so that's the starting amount. And the rate is not given, so we're going to have to find out the rate. So if you start with 20 of them, and we're going to need to solve for R, the T is 30 minutes. Now, since the directions say to use minutes, I'm just going to go ahead and use minutes. So 30 minutes rather than putting half an hour. That way the units are the same, minutes and minutes. And then if it's going to double its size, then from 20 bacteria, there's going to be 40. And now we need to solve for R. So the first thing to do, divide both sides by 20 so that we can isolate that E. On the left, that equals 2 on account of the doubling. That is the double part. And then take natural log of both sides. On the left side, when you take the natural log of the E, they're going to cancel, leaving just R times 30. And then to solve for R, just divide both sides by 30. So it turns out that R is going to be some type of decimal, whatever ln of 2 divided by 30 is. So hop on over to the calculator and take the natural log of 2, make sure that's in parentheses, divided by 30. And of course it's a positive number because that means that it's growing. If it's a negative number right there, that means it would be something that's shrinking. But this population is growing. So R equals a 0.023. So if I go back to my PERT formula, it's now going to look like start with 20 bacteria, and then it's going to grow. So E to the 0.023 times T. Most likely there's one more thing I need to do. So go back to the directions and let me just clean it up a little bit. Oh, so all I need to do is, so I did this part, find the equation after T minutes. So did I use T? Okay, I used T. That's good. Also, graph this function. So basically, I could use the graphing calculator, but I also know that it's going to start with 20 bacteria. So that is when T equals 0, when no time has passed. And then it's going to grow exponentially like this. Now, if I use the graphing calculator, it's going to show me this part as well. That part right there is actually if we went backwards in time. And since we can't usually do that, then this would be the graph. You know what? Before I hang up, there's one other thing we could do is right here, if you put 30 minutes, then it's going to double. So this would be 40. There's a little more information. That looks better. Let me color this in. There we go.